composition of functions. So f composed g of x, or it can also be written f of g of x. And I tried to type that here, and I apologize for my writing. Writing with the mouse is I'm getting better at it, but it's a little bit difficult. But this is f of g of x. Now, what does this all mean? Well, what it means is it means to take the g's function rule and input that whole function rule into the f function rule, and we're going to input it into the x in the function rule. So f of g of x is standing for taking the function rule of your g function. So you take this g's function rule, and then you input it into the x of the f function rule. So far in your math careers, you've been practicing problems like this, maybe f of 3, and then you have a function rule, maybe it's 3 plus 4x or something like that, and then you'd put that 3 in for x, and you would solve it out. Well, now instead of just having a number that we're inputting, we're going to be inputting a whole function rule. So we're going to take a look at problem 3. We'll practice 2 with inputting one function rule into the other function, and then we'll also take a look at how we can apply composition of functions with numbers. So heading down to problem A, we've got two function rules. We've got f of x is equal to x squared plus 1, and then we've got g of x is equal to x minus 2. So first off, I'm going to find g composed of f of x. The first thing I am going to do, though, is I am going to rewrite that in the alternate form. I'm going to rewrite that as g of f of x. So it is written two different ways, g composed f of x, that little symbol, or you can write that as g of f of x. Now what this is communicating to me is it's telling me to take f's function rule, which is x squared plus 1, and input that into the g function. So it'd start to look like this, g of x squared plus 1. And then the g function rule is x minus 2. So with function rules, whatever number is in the parentheses of the name of your function, that's the number that you're going to input into the function rule. Well, here we have a whole function rule that we are now going to apply into the g function. So g's function rule is x minus 2, but I'm going to replace the x with this function rule. So it's going to be x squared plus 1. That's where the x used to be, minus 2. So the x used to be where I'm putting the parentheses there, and then that's now replaced with the function rule of the f's function rule. Now I have x squared plus 1 minus 2. Basically, I don't need the parentheses because inside the parentheses, there's nothing I can really simplify. So really, I would just combine my terms of 1 and then minus 2, which brings me down to negative 1. So my final answer, my final function rule after the composition would be x squared minus 1. So I took the f's function rule and I applied the whole function rule into the g's function rule. So we're going to flip it and we're going to look at it the other way. So in algebra, you learned about the commutative property. We're going to kind of see our composition of functions commutative. Do they represent the same thing when we flip them both ways? So let's go look at f composed of g of x. So that is going to be f of g of x. So now this is communicating to me and saying take the g function, which is x minus 2, and we're going to input that into the f function. So there we take the f function. So f function is x squared plus 1. So I take the x out, and now I'm putting in the g function rule. So there's the g function rule going in. So where I have the parentheses, that's where the x used to be in my f function rule. And I've now input the g into that position. Now from there, I'm going to continue to simplify. Now x minus 2 squared represents this, x minus 2 times x minus 2, which is going to be a FOIL problem, x squared minus 4x plus 4, and then I still have the plus 1 outside. And that leaves then my final answer is going to be x squared minus 4x plus 5. So there would be my final result after doing a composition of functions. In that case, the order of operations I'm following is I'm taking the g function, placing it into the f function, and then getting my final result. So there's how we can do a composition of functions with function rules. And the next thing we're going to look at is how we do a composition of functions when we have an actual number that we can input into the function rule. Now I'm going to need to erase this. Is that okay if I erase that problem? Any objections? You can turn on your mic, let me know. Are there any questions or anything that you would like clarified from those two problems? So as always, I am recording this and I'll have it posted to our class page in just a second. All right, so we'll have two additional examples here. And for some reason, my computer is thinking pretty hard right now. So let's see if I can get this erased. That should give me enough room. So I'll keep the red one up there. And we'll head into problem C next. All right. So problem C, what is G composed F of negative 2? Again, I like to rewrite it. So G of F of negative 2. So similar to before, the f of negative 2 is inside the g function right now. So the f of negative 2 is going to be what function we're going to start to apply first. And f of negative 2 is going to stand for, I'm going to take a negative 2 and I'm going to input negative 2 into the f function rule. So g of f of negative 2 means I'm going to take g of, the f function rule is x squared plus 1. So I'm going to take that negative 2, put it into the f function rule. So what I've done now is I've taken the f function rule, f of negative 2, and I've now input that negative 2 into its function rule, which was inputting that negative 2 in for the x. So I'm using this function rule up here. So that is something of function rules that you have been introduced to. So f of 3, we put a 3 in for the x. F of negative 2, we're going to put a negative 2 in for the x. Now I simplify that. Negative 2 squared is 4, plus 1 is 5. So that's going to be g now of 5. So now I've applied negative 2 into the f function rule, and I get a result of 5. Now that 5 becomes the input of the g function. So now the g function rule is x minus 2. So g of 5, now I'm going to take the x, replace it with a 5, and get my final result, which is going to be 5 minus 2, which is 3. So I've taken the f function, applied negative 2 into the f function, you get a result of 5. After getting the result of 5, that's going to now input into the g function, and we get our result of 3. So very similar to above, we're going to check what happens if we reverse, and you'll see that again, you're not going to get the same result. So let's just see what we get when we do the g function first and then the f function. So this is going to be f of g of negative 2, which first I would apply the negative 2 into the g function. So this is going to be f of negative 2 minus 2. So I'm using the x minus 2, but instead of the x, I input that negative 2. So now negative 2 minus 2 is going to give me negative 4. So then I'm going to have now f of negative 4, which in the f function rule is going to be negative 4 squared plus 1. And I got a little lag there. There we go. Negative 4 squared plus 1. So that goes back to now f negative 4, put the negative 4 into the f function. And then anytime you're inputting a value in for your variable, it's a good idea to just put it in parentheses. So negative 4 squared is actually negative 4 times negative 4, which is positive 16, plus 1 is going to give me 17. So again, we see that when we have a composition of functions, if you do flip the composition, you will get a different result. So it doesn't do any good to just solve it one way and then that's also going to be the answer the other way. We do have to apply both compositions and see our results of what we get when we do both of those compositions. So we're going to continue working with functions. So yesterday we looked at adding, subtracting, multiplying, dividing. Today our goal is to complete compositions of functions where we take one function rule and then we're going to apply it into another function rule. And then we'll also look at these function rules when we input a number into their functions. So I'm going to stick around and work on delta math, but if you are ready to work on your own, you can head and break off to work on your own on your delta math assignment. But if anyone sticks around, I will be heading into delta math to practice some of those problems next.